Is the function linear or nonlinear? All right, so we have a collection of points essentially, and they do define a function because basically we have a single y value for every x value, right? And when we look at the list, we're trying to determine if it's linear or not by basically checking if we have a constant rate of change. In other words, is the slope the same? For a line, the slope is always the same. If the function is not linear though, that won't be true. And what that means is that as you move from one x value to the next, the y value will change in different ways. So when you move from -2 to -1, you can see that's a unit change in x. But what's the corresponding change in y? Well, it looks like it's a change of 7, right? Because we go from -7 to 0. So it seems like it's increased there by 7. Now, it's the same distance from -1 to 0 as it was from -2 to 1, correct? So on the x-axis, it's the same amount of change that's occurred there. So we expect a change in the y-axis to be also the same change as it was before if the function is linear. So we'd expect to go from 0 to 7, but instead we go from 0 only to 1. So the change is quite different there. And that means that this function, the first one, is not linear. All right, now for the second one, it's a little different. When you go from -2 to -1 on the x-axis, you go from -7 on the y to -5. That's a change of 2, right? We've increased by 2. When you go from -1 to 0, which is the same amount of distance on the x-axis, a step away, right? Just one step from -1 to 0 is just one step. We again have just a change of 2, right? From -5 to -3, we've increased by 2. And when we go from 0 to 1, right? Again, we have a unit change in x, and that produces a step that's, again, 2 higher on the y-axis. So we go from -3 to -1. And then from 1 to 2 on the x, again, a unit step on x produces, again, a change of 2 on the y-axis. We go from -1 to 1. So it appears for this function, we're dealing with a linear function. And the reason why we think it's linear is because, essentially, the rate of change is constant, or in other words, the slope is constant. By the way, if you wanted to determine the slope, you could just use the slope formula, right? That has basically the change in y, so y2 minus y1 over the change in x, x2 minus x1, right? And if you did that for our example, you could take any pair of points here. For example, let's take this pair of points, right? The y coordinates would be 1 minus -1, 1 minus a -1, and the x coordinates would be 2 minus 1. And then from there, we'd end up having 1 plus 1 over 2 minus 1, which is just 1. And then you get essentially 2 over 1, or just 2. So the slope is 2, and that's why we saw for every change from y to y, we increased by 2.